Good morning, class, and welcome to this lesson on kinematics for acceleration. Today we will be able to define acceleration and give examples of positive and negative acceleration. So here we go. Acceleration. Acceleration is the rate of change of the velocity. Okay, it is the rate of change of the velocity. So let's go down this little path here. We have a thing called displacement. Okay, we'll call it delta x. Okay, velocity was the change in x. So velocity was the change in x over time. It was the rate of change of displacement. Acceleration is going to be the rate of change of velocity. Okay, so you can see we're kind of building up here. Okay, so velocity is how much was x changing. Okay, acceleration is how much is velocity changing. Okay, it's like building on itself here. Okay, so when we look at our units, delta x, this is measured in meters. This is measured in meters per second. X over t, and this is delta v over delta t. So this is meters per second per second. Or in other words, I can put that as meters per second squared. Meters per second squared, okay? So this is our formula. This is our formula right here for average. This is our average velocity. I'm going to say the same thing about average velocity as I did about average acceleration. I'm going to say the same thing about average acceleration as I did about average velocity. Don't confuse average acceleration with instantaneous acceleration. We will have different formulas for that, so you will have to be aware of that, okay? So we have our units, meters per second squared. So what does this mean really? Okay, how much does the speed change? Okay, right here we have a picture of a plane and it's taking off, okay? And right up here it tells us the acceleration is 9 kilometers per hour per second. 9 kilometers per hour per second. So notice, before I even move on, notice here it's 9 kilometers per hour per second, or 9 km hours seconds. Notice that does not match meters per second squared, but that's okay. It still works. The units still work just fine. These are what we call standard units. These are the units we're going to use most of the time, but these still work. Because acceleration, really what it is distance per time, or distance per time, okay? So this is 9 kilometers per hour per second, or 9 distance per time, okay? So right here, at time 0, this jet is not moving. It has a velocity of 0. After a time of 1 second, it now has a velocity of 9 kilometers per hour, okay? So in 1 second, its velocity changed by 9. It went from 0 to 9, okay? After 2 seconds, it went from 9 to 18. And that's why the acceleration is 9 kilometers per second. It's changing by 9 kilometers per hour per second. The acceleration is changing by 9 kilometers per hour every second. So as you can tell, at this next time right here, it's going to be 27 kilometers per hour, because after one more second, it's going to increase another 9 kilometers per hour. Okay, so that is acceleration. Okay, so pretty simple. Things accelerate. We are kind of used to that, but now I'm going to have to change it up on you a little bit. Acceleration, because acceleration is also a vector, acceleration can be negative. Acceleration can be negative. I mean, if we look at our acceleration equation, delta v over delta t, where delta v means v final minus v initial. If v final is 10 meters per second and v initial is 16 meters per second, over, and we'll say over, 2 seconds or something like that. 10 minus 16 is negative 6. Negative 6 over 2 is negative 3. So what does negative acceleration means? Negative acceleration, which is commonly called deceleration, okay, commonly called deceleration, is slowing down, Or, in order to make this even more specific, it is where the acceleration and velocity vectors are opposite. The acceleration and velocity vectors are opposite. So let's look up here. Let's look at this example, okay? So we have this car here. At time t equals 0, its velocity is 28 meters per second. So this thing was traveling down the road, and at this time, time 0, it's traveling 28 meters per second. But now it's going to start slowing down. After 1 second, it's going from 28 to 23, then it's going from 23 to 18. You can see it's changing by 5 meters per second in this direction, in that direction. So we're going to say this acceleration is negative 5 meters per second squared. So just to be clear, when something is speeding up, I'm going to say speeding up, that is when the acceleration vectors and the velocity vectors are in the same direction. If someone is walking this way, they're walking, so they have a velocity this way, and then they start accelerating this way. And they start accelerating. That's not a good picture. If their velocity and acceleration vectors are in the same direction, they are speeding up. And if they are slowing down, that means their velocity vector is one way and the acceleration vector is another way, okay? So that means they were going fast. And then now they are slowing down. So, acceleration and velocity, and there's one more thing I want to point out to you. Once again, if we call velocity this way positive and we're slowing down, then the acceleration is that way, okay? Because it's going to be negative, so this is negative acceleration, okay? If we decide to call this way positive, we'll say velocity is positive this way, and we'll say we're speeding up, that means the acceleration vector is going to be in the same direction, and it's going to be positive. So it all depends on the given situation. You have to look at the situation and then figure out your signs. You have to look at the situation and figure out your signs. So notice this acceleration vector and this acceleration vector are pointed in the same direction. They're pointing both to the left. But depending on the situation, in this one, I'm calling velocity positive to the left. That means acceleration is positive, and it's speeding up. In this one, because I call velocity to the right positive, acceleration is pointing to the left. That means it's slowing down, negative acceleration, okay? So just be careful with your signs and make sure you're putting the right sign in when you're trying to solve these problems.